Hi all, welcome to Heights to Fly. Today we are discussing about rational numbers and how to represent it in a decimal form. Then first we go to rational numbers. In previous class in many times we discussed what is a rational number. Once again I am telling what is a rational number. Any number which can be represented in the form of P by Q, where P and Q are integers, where P and Q are integers and the value of Q should not be equal to 0. Any number which can be represented in the form of P by Q, where P and Q are integers and the value of Q should not be equal to 0. We can divide rational numbers into terminating, non-terminating, recurring or repeating. Non-terminating, recurring or repeating. Okay. What is an example for terminating rational number? 2.17 is an example. That is it is terminating after two decimal points, 0.35. What are the examples for non-terminating recurring numbers? 0.3333, etc. 1.272727, etc. Another example 0.101001000, etc. Such numbers are one under the category non-terminating repeating values. Let's discuss about the representation of a rational number in decimal form. Consider an example 0.375. We can rewrite the value in the form 375 divided by 1000. Here 3 decimal points, so we have to divide it by 1000. 3 zeros. 3 decimal points, so 3 zeros. We can rewrite it using 375 divided by 10 raised to 3, which is equal to, according to factorization, 375 5 7 5 5 1 5 5 3. Okay, then we can rewrite 375 in the form of 5 raised to 3 into 3 divided by, we know what are the factors of 10. 2 into 5. 2 and 5 are the factors of 10. So we can rewrite it as 2 raised to 3 into 5 raised to 3. Please note this, 2 raised to 3 into 5 raised to 3. Next terms 0.104. Again 104 divided by 1000, because 3 decimal points. We can factorize it as 104 to 52 to 26 to 13. So 2 raised to 3 into 13 divided by 2 raised to 3 into 5 raised to 3. Okay. So another example 0.0875. We can rewrite it as 875 divided by 10,000, because 4 decimal points, 4 zeros. 875 divided by 10 raised to 4. Okay, can rewrite it as 875 divided by 2 raised to 4 into 5 raised to 4. Okay. Here, from these examples, we can learn a theorem. The theorem states that let x be a rational number whose decimal expansion terminates then x can be expressed in the form P by Q where P and Q are integers and coprimes, and the prime factorization of Q is of the form 2 raised to n 5 raised to m, 2 raised to n 5 raised to m, where n comma m are non-negative integers. Let consider once again, let x be a rational number. Consider this, let x be a rational number whose decimal expansion terminates. This is a terminating rational number. Then x can be expressed in the form p by q. X can be expressed in the form p by q. P and q are integers and coprimes. And the prime factorization of q is of the form 2 raised to n into 5 raised to m. 2 raised to n into 5 raised to m. We can factorize 875 as 1 37 7 5 5 3 5 5 7. So we can write it as 5 raised to 3 into 7 divided by 2 raised to 4 into 5 raised to 4. Then we can rewrite 5 raised to 3 and 5 raised to 4 get cancelled and the remaining 5 only. So here the values of m and n are n is equal to 4 and m is equal to 1. N is equal to 1. Here also we can write 13 divided by 5 raised to 3 where n is equal to 0 and m is equal to 1. Okay, so the theorem is proved. So again, if it is a non-terminating, it's a terminating rational number, we can represent it according to prime factorization in the form 2 raised to n, 5 raised to m. Let's go to another theorem. It is also relating to the same. Let x is equal to p by q be a rational number, such that the prime factorization of q is of the form 2 raised to n, 5 raised to m, where n comma m are non-negative integers. Yeah, n and m are non-negative integers. Then x has a decimal expansion which terminates. The same case we proved previously. That is, if we can represent it in p by q form according to prime factorization, we can represent in it 2 raised to n, 5 raised to m. Then we can say that x has a decimal expansion which terminates. In all these cases, we discussed about terminating rational numbers. Let's consider another example. 1 by 7. 1 divided by 7, and we divide 1 by 7 point 0 1 7 3 34 7 28 2 20 2 14 6 0 8 56 4 40 5 35 50 7 49 1 0 1 7 3 30 4. Okay, again the same pattern is repeating. 1 4 2 8 5 7, again 1 4 The same pattern is repeating. Here the remainders are 3, 2, 6, 4, 5, etc. Okay. So 1 by 7 is equal to 0.142857. So this is the representation. Let's go to another theorem. Based on this example, theorem states that let x is equal to p by q be a rational number such that the prime factorization of q is not of the form q raised to n 5 raised to m, where n comma m are non-negative integers. Then we can say that then x has a decimal expansion which is non-terminating repeating. Once again, if we get x is equal to p by q be a rational number such that prime factorization of q is not of the form 2 raised to n 5 raised to n. Here it is not in the form of 2 raised to n 5 raised to n. We can't represent in such a because it is non-terminating repeating. But in the previous case we can represent it in the form 2 raised to n 5 raised to m. 2 raised to n 5 raised to m. But for this value we can represent it in the form. So that is the difference between all the theorems explained in the terminating and non-terminating repeating values. On next class we will discuss more about what are some more examples relating to this. So thank you for watching. Subscribe and share for new videos.